All right, guys, this should be the last part of this lesson. If you didn't spend time playing with Desmos, go back and do that. You've got to do that before you go on to this part here, because you really want to understand the graphs visually before you go in and start trying to understand them numerically here. So you get 3 questions here. Without graphing, this is not using Desmos. Determine the domain, in other words, the x values that are valid for this function. And hopefully you go, well, you can't have a negative inside here, so there's only certain numbers you could plug in here. You could plug in 1 or 2 or 3 or 4 or 5 or 6. Any positive number you could plug in for x, it would work. You could even plug in -1. -1 plus 8 is 7. That would still keep this value positive. Think about what value in here you could not plug in that would make this radicand negative. And the first integer hopefully you come up with is -9 or -10 or -11, something bigger than 8, because it would make the radicand, this stuff underneath here, negative. So basically anything that's bigger than 8, any negative number bigger than 8. How do you do that mathematically? Well, you take this radical and you set it equal to 0, or I should say greater than or equal to 0. And you solve it, just like a little mini equation. Sometimes you can do this with mental math. It's better to start approaching it in the algebraic way, I think, than just try to do all mental math. But mental math is great to understand it. You try to solve this equation, well, duh, you subtract 8 from both sides, you get -8. And this equation shows that x has to be bigger than or equal to -8. If it was -8, you could plug that in, you get 0. There's a square root of 0, that exists. But in other words, in words, this is saying x cannot be smaller than -8. It can't be -9, it can't be -10, it can't be any number to the left of -8. This is saying x has to be greater than, more than, to the right of -8. Now you just did a graph a minute ago, and hopefully you figured out that when you add a number inside the radical, it shifts the graph to the left. So this is really agreeing with what you learned graphically. Hopefully there's a connection between those two. You don't need to graph this. I'm just showing this to kind of remind you, maybe refresh your brain about what you just learned on here. This shifted the graph to the left, so it shifted my domain. The domain is all x values bigger or to the right of -8. Sorry. All right, these two, approach them algebraically. You know, the value inside here has to be bigger than 0, bigger than or equal to 0. So that's the equation I set up. 3/4 x minus 6 is greater than or equal to 0. You solve that like you solved that the first week of school. You know, pre-algebra you could solve that. Add 6 to both sides. You get that. You should know how to clear fractions by now. I'm going to show this in 2 steps. Multiply both sides by 4 to get the denominator to cancel out. And you get 3x is greater than or equal to 24. Clear the 3 by dividing by 3. And you say that x has to be greater than or equal to 8. I often would suggest you plug that number back in and just play with it. And do, okay, 8 times 3 is 24, divided by 4 is 6. 6 minus 6 is 0. That's what we're trying to get. 0 is sort of the tipping point where this thing works or doesn't work, where this value is positive or negative. All right, last one, same idea. There's some sort of extra information here you don't even need. The domain only depends on this radicand being positive. So you don't even need this. If you remember from the Desmos thing you did, this shifted the graph, I believe, upwards. Who cares about that? Domain is the x values. All we care about is this radicand positive? Is it greater than or equal to 0? The same idea. You need a fraction for this one. Add 8 to both sides. And to get rid of the 7, you divide by 7 on both sides, and you get 8 over 7 as a mixed number. This would be 1 and 1/8, I believe. Oh, take it. That's 1 and 1/7. There's my first mistake. 1 and 1/7. So close to 1 and 1/8. 1 and 1/7 on there. And of course, if you plug that value 1 and 1/7 back in here, it would get this radicand equals 0, which tells you it's sort of the tipping point on there. So what you've just answered is this is the domain of the function. Values greater than or equal to positive 1 and 1/7. Scribble that out. X value is greater than 8, or x greater than or equal to, or x value is greater than or equal to -8. So, second, approach at Desmos here. Take a few minutes. You're going to want to, maybe pause this and come back to it. Consider each of these graphs, and I'm calling it a parent function. That just means it's the original function. It's the basic radical function. Each one of these is manipulating that function. In other words, it's shifting it, or stretching it, or bending it, or flipping it, doing something to it. You do a lot of this in geometry and a lot of this in Algebra 2 and pre-calc. A lot in geometry, actually. It's called transformational geometry, where you transform the graph. Describe how each of these functions differs from this original. So if you type this in as your function 1 and always keep it in there as 1, you can always look at 1 and compare it to 2. Look at 1 and compare it to 3. Look at 1 and compare it to 4. Look at 1 and compare it to each one of these. You might even know how to do this already from what you've already learned. You know, some of these will shift it left, some of these will shift it right, some of these will shift it up and left, or down and right, or, you know, combination of the two. That's a great time to pause. Again, I'm not going to show you what this does. Take a few minutes. If you can do this, you've learned quite a bit today. I think this one shifts it left. I think this one shifts it right, which is kind of weird. You'd think positive would shift it the other way, and negative would shift the other way, but it doesn't. This is a combination. This, I think you've learned, shifts it up, and this shifts it left. There's two things going on. This one shifts it down, and this one shifts it left. So the graph's changing on there. This one shifts it. This does something else to it. If you double all of these values, whatever the heck this garbage is, think about if you double the values on one side of the equation. It's going to stretch it vertically. It's going to make it steeper, essentially. And this one, I think, shifts it right and up. The entire graph shifts. This is a weird one. If you put a -1 in front of the rad x, think about if you take all of the x values, or all of the input values, after you take the radical, and you make them negative. Think about what happens. Your curve looked like this before. If you make them all negative, you're now flipping it. Essentially all the y values become negative because you're flipping it down. Plug this in Desmos. This should flip it. This one here, you say you can't have a negative inside a radical. That's true. Think about what numbers would have to get plugged in here to make this work. If there's already a negative sign here, the only inputs you could have here would be negative numbers. So all the domain, all the x values are negative. This is flipping the graph the other way. It's flipping the curve that would be going this way and flipping it over this way. And this one's the ultimate. This is like the double flip. This is sort of a combination of these two. This is flipping it one direction, this is flipping another direction. It's kind of interesting to see what these graphs look like. And this might be the time where you start to realize this is related to parabolas. It's parabolas going the other way. You know, going right or left, usually right. But it's only half of the parabola because it's a square root sign, and square root only has positive inputs. So the homework is up there. You know, I do not want you to actually go and graph 9 through 14 like it says in your book. I want you to just verbally describe how the changes are affected like this. Just tell me what's going on. We'll come to a point where we might graph them. This should save you some time, you know, in terms of what you're actually doing on here. I want you to understand how the parent function, y equals rad x, is affected by each of these changes on 9 through 14. So these are just verbal descriptions. If you go and graph it, that's fantastic. You don't even need Desmos. You could use Desmos if you want to check it. You know, there's some tricky questions in here maybe as you get to the end. Hopefully it's not too bad of an assignment. Have a great day. We'll see you tomorrow. We'll be back on Tuesday.